first thing you want to do, like with all the other ones, label each side U and V. So I picked this as my U, this is my V. And then you just want to outline the U primes, V primes, and then just write the U and V again so you have everything organized. So for U, it's x squared plus 1, and for V, it's x plus 1 squared. And your U prime is 2x, and your V prime, you have to use the chain rule for this one. So you split it up as 1 for the derivative of the inside times the derivative of the outside. So it would be 2 times the stuff on the inside. And when you multiply this out, you get 2x plus 1. Or 2x plus 2 rather. And then you just do U times V prime plus V times U prime. You just have to make sure that in this step you get a prime on either side and then you multiply it by the opposite non-prime one. The order doesn't matter because it's multiplication. So when you multiply this out and add them, you get a big long string of numbers. So to save from that, I'll just show you what f prime of x is. And it simplifies to 2x cubed plus 4x squared plus 4x plus 2.
Okay. Do you guys follow that?
Yeah.
That makes sense? You think it's right?
Yeah.
Wait, so it's 2x cubed plus 4x squared plus 4x plus 2?
And he skipped the foiling part, you know, he did it on his paper, but you just double check that. Yeah,
It's neater.
and then 2x and 2x is 4x and then 2. Yeah, that's all good. Alright. Any questions? Alright, let's go on to our next one. Andrea?
I think you're the only teacher that calls her by her proper name.
Well, I haven't been all year, and I just found out last week that I had been saying it wrong all year, so.
It's fine, I don't really care. So, like Jay said, we label them U and V. And I'm just gonna write them like he did. So this is x plus 1, and V is square root of x plus 2. And so we take the derivative of each of them. So for U, it's just 1, because the derivative of a constant is 0. And then for V, it's 1/2 x to the negative 1/2. Yeah. And then we can just put it into the formula. Is U so that would just be 1 because, so I'm not going to write it because it's just multiplied times V, which is root of x plus 2. And then x plus 1 times 1/2. And you could simplify that, but it's not really necessary.
Okay. Alright, yeah. And let me show you guys the simplifying, just so you guys can see what the book will do. Thank you. The book will simplify this further. So you're going to have, your square root of x plus 2 and then if you distribute this x 1/2 x to the negative 1/2, okay, 1/2 x to the negative 1/2 times x, you'd add the exponent. So 1 plus a negative 1/2 is a half. So that's going to give you 1/2 x to the 1/2. And then plus, you have to distribute it to the 1 as well, 1/2 x to the negative 1/2. Alright, and the reason why we can do that, or the reason why we might want to do that, is because here we have a square root of x, and this x to the 1/2 is the square root of x. So you could rewrite that as 3/2 x to the 1/2 plus 2, and if you want you can write this last term here as 1 over 2x to the 1/2 as well, or 2 root x. So my guess is that the book would actually end up giving us this as our answer. Okay, I'm okay if you stop a little short of that, but there you have it. Okay, any questions, comments? Okay. Alright, so next, Christina. And while they're explaining, make sure you're following. This is how you can, solidify the whole method in your head.
Okay, so this is my u, this is my v, so rewriting it, v x squared, and my hand is getting everywhere. Okay, whatever. Plus x plus 1, and then same for v, would be x minus 1. And then the u prime would be, I don't know where I wrote this, 2x, just 2x plus 1, because the 1 gets cancelled, this goes to 2x, and then this just becomes a 1 when you take away the exponent, and then the v prime would be just 1, like kind of an Andreas, except this one's a minus, but the constant turns to 0. And then when you plug it into your equation, u prime times v plus v prime times u. The u prime was, am I doing the way? 2x plus 1 times x minus 1. And 1, which I'm going to leave there for now, times x squared plus x. I'm not very good at this, plus 1. Okay, and then when you start factoring this and simplifying it, it becomes equals 2x squared minus 2x plus 1, plus x minus 1 plus x squared plus x plus 1. And then your x squareds get turned to 3, this one and this one become 3x squared. And then after that you have negative 2x, x, and x. So since this is minus and these are plus, these get cancelled. And then your negative plus your 1 also gets cancelled. So it's just 3x. I don't know why that's circled.
That's good. Alright, does everyone follow that? Do you have any questions? Real quickly here, think kind of backwards. What real simple function would have a derivative equal to 3x squared? X cubed. Alright? X cubed. This is one, if you really knew your stuff about factoring, you guys remember the sum and difference of cubes?
Yeah.
Probably not, and that's okay. Alright, this actually is a factored form of x cubed minus 1. Okay, which if you were given that, then you could just jump right there. Alright? If you happen to recognize that, kudos to you, because you're 1 in 100, alright? Or more. But, but, you know, you could rewrite it and then get your thing, but that works, okay? That works, it's good. Alright, next, Jordan.
Right. Okay. I'm the worst at writing on the smartboard, so this is gonna be great. Okay, so u of x is just x. B of x is x to the 7 plus 15 cubed. Okay, then u prime x. I'm writing really bit. Is 1. And v prime x. Okay, so for v prime x we had to use the chain rule, so it's going to be 3 times x to the 7 plus 15 squared. Okay, how do I extend the page?
You scroll down on the right. Yeah, there you go.
Thanks. Okay, and then we have to multiply that by 7x to the 6. Okay, and then that's going to give us 21 x to the 6 times x to the 7 plus 15 squared. Okay, and that's going to be v prime x. Does everyone get that? Because I did not get that first. Okay, so now that we have that, we can use the formula to actually figure out what this is. It's going to be x times 21 x to the 6 times x to the 7 plus 15 squared plus x to the 7 plus 15 cubed. Alright. Now we can factor out an x to the 7 plus 15 squared because we have this here and then it's cubed here. So once we do that, it's x to the 7 plus 15 squared. So here we're just factoring it out. Times 21 x to the 7 plus x to the 7 plus 15. And then that gives us x to the 7 plus 15 squared times, we're just going to add these together, so it becomes 22 x to the 7 plus 15.
Okay, any questions? Comments? Anything? Alright, now, this is the first time that we've seen, at least today, ones where this happened, okay? And by the way, she didn't forget about the u prime times v, but remember u prime was just 1, okay? But you'll see this a lot when you have to use the chain rule within the product rule, okay? We have this common factor that results, and we can take that out. In this case, it was the x to the 7th plus 15 squared. So that's what we took out to here. And then you look at what's left over. What was left over was the x times the 21x to the 6th. So that's where she got the 21x to the 7th. And then what was left over was the third one of these. Okay, because we only took out that squared. So the third one is right here, the x to the 7th plus 15. And then she simplified, okay? Alright. That looks good. Alright, our next one then, Eric.
Alright, so first we'll get the U prime and V prime. Sorry, I got my hand ready. So U is x squared. Right here. V is x plus 7 Q. U prime is just 2x. You bring that there. And V prime is a little harder. So you have to use the chain rule. So you bring the 3 in front. So it'd be 3 times x plus 7 squared. And then you get the derivative, multiply that by the derivative of the inside. But that would just be 1 since the constant is 7 and the x would be 1. So technically you have to multiply that by 1, but it's still that. Then you have to plug it into the formula, or U times V prime plus V times U prime. So that would be 2x times x plus 7 Q plus x plus 7 why am I thinking this? Yeah, this would be 3 times x plus 7 squared. I did that wrong. Oh, that's a 2 times, hold on, I'm lost. Okay, x plus 7q times 2x. And this would be x squared, not 2x. Alright, and now you can factor out x plus 7 squared. So then it goes to then you would have to put x squared plus 3 plus plus x plus 7 or times x plus 7.
Okay, it would be the x squared times the 3, right?
Yeah.
So 3x squared.
Okay.
X squared,
Oh.
yeah, 3x squared. Well, just use the flat part, don't try to use the tip of that. Yeah, there you go,
Oh.
no erase.
3x squared
And then you've got the
Time.
2x and the
Right.
other x plus 7.
so times
Well, now that's plus.
right plus x plus 7.
Well, that was times the other x plus 7. See, the 2x is times the x plus 7, right?
Yeah. Okay.
So it'd be 2x times the third x plus 7 there. So parentheses x plus 7.
Yeah. And then you have x plus 7 squared right now. X plus 7 squared times 3x squared, and then you do plus, would you just distribute this? Plus 2x squared plus 14x, and then for the next one you can do x plus 7 squared times, you can just add these and you get 5x squared plus 14x.
Alright, good. Alright. So again, we stay organized, and you'll notice, because we wrote stuff out, we caught some mistakes, right?
Yeah.
Because we wrote stuff out, we realized, oh wait, I used u prime instead of just u.
Right.
So this should be our x, x squared, not our 2x. So, but you're not going to catch that if you're just kind of trying to do everything in your head. All right, so good. All right, let's see, Maria.
So we need to identify the u, which is 7x, and then the v, which would be square root of 4x squared. No, wait. Plus 7. And so then we just need to do the u prime v plus u v prime. So then it just becomes the u prime would be 7x to the 6th power, and then the v prime would be 4x squared plus 7 times 1/2 to the negative 1/2. And so then you go back, and then that becomes 7 x to the 7th square root of 4x squared plus 7 plus x to the 7th. So you write out both of the formulas, and then you go on to simplify it. So it becomes 7x to the 6th square root 4x plus 7 plus x to the 7 times 4x squared plus 7 to the 1/2. And then that simplifies even further to 7x. To this quite complicated formula, which, as Mr. Hickson told me, you do not have to simplify even further. So then you just leave it at that.
Okay. All right. So. Plus. So yeah, so we have this to the negative 1/2, and then you got the times 1/2 part there. Okay. Again, this is one where your book would probably simplify, and let me just show that to you so you've seen it.
Mr. Hickson?
Yeah.
Do we need to simplify on the IB exam? Or can we leave it?
I don't think you would need to simplify beyond this.
Okay.
I can ask Miss Barheim just to make sure, but I don't think so.
Okay.
I know they don't care if you rationalize denominators and that sort of stuff, even if you left to like 6/3 instead of writing it as 2, they're not gonna take off for that. But for this one, what we could do is, if we wrote this as 7x to the 6th square root of 4x plus 7, oh that was squared, lost that somewhere, but, okay. But then plus x to the 7th over 2 times the square root of 4x squared plus 7. Okay, you can get a common denominator. Alright, and the reason why you may want to do that is because watch what'll happen. To get the common denominator with a 2 root 4x squared plus 7, you'd multiply it by a 2 and another square root of 4x squared plus 7. Alright? So what that'll do is actually cancel out the square root here, which does make it end up being simpler. You have a 14x to the 6th times a 4x squared plus 7 now to the first power, because you squared a square root, and then plus an x to the 7, and that whole thing would then be over this. Okay, you could keep going even. 14 times 4 would be 56 x to the 8th plus that x to the 7th plus 14 times 7 would be 98 x to the 6th all over 2 root 4x squared plus 7. Okay, so that is probably what you'd end up seeing in the back of your book if you checked your answer. Okay, but I would be fine if you stopped where Mary did. Okay. All right. Any questions? All right. Listen, don't check out here. Okay. Watching these done, seeing and listening to the explanations is how we recognize parts where we're gonna mess up, okay? And we're gonna mess up sometimes. Alright? But you can avoid some of that by focusing well here, okay?
Okay, so do you want me to do like everyone did?
Yeah,
Because
go
I
ahead
did
and
it
show-
differently.
Go ahead and show all
Okay.
your work there.
Okay, so here the derivative is x over 2 to the negative half. So this is right?
Mhm.
Okay. And the derivative of this, so is 2x. Any questions so far? Okay, so then is this times this, right? Because it's times this one, and which is v, and plus this times this. So this is u. Does it make sense? Okay, so then you multiply, so this is x, because you add this and this, so it becomes 3/2, then plus 4, because you're just like multiplying this and this. Then here it's 2x. You're just multiplying. Then okay, so then this is x. And then this is actually 2x to the 3/2 too, because this is 1 and this would be like a half. So you just add both of this, so you have this. And now you can add both of these, so it's x over 2 plus 4 Because this becomes this, and then plus this. And now since it's 2 and 2, we can just make like one big one. So this is 5x over 2 plus 4.
Alright.
Wait, I'm confused. So once you go from, like, once you combine
Which
X,
ones?
the second to last step, how did
Okay.
you get plus 3/2 instead of the negative 1/2?
Wait, where?
The second to last step.
Here?
Yes.
Okay, what's your question?
How did you get 4x to the third 3/2?
Oh, because you're doing the common denominator with this one. Because you're adding this and 2, so you make 2 divided by 1, 2 times 2, 4. You're just doing the common denominator because you're adding them.
She's changed the order of the second and third terms.
Okay.
See, the x to the negative 1/2 is at the end now.
This
Oh, okay. That makes
is
sense.
this.
Yeah.
Okay, thank you.
Okay. Alright, thank you. Okay, so hopefully, I mean, you can see some different ways folks are doing things. You know, we've got our 4x to the negative 1/2. But also you can kind of see how the fractional exponents can help you see some relationships that you would miss if you had radicals. If you had all radicals, okay? You know, up here if you had, well, you know, when you were multiplying the x to the negative 1/2 by the x squared, you're adding the exponents, so that's 1.5 or 3/2. Okay? But good explanation there. Alright. Amy drew the short straw. This was probably the hardest one.
Probably.
Okay.
Okay. Whoa, that's hard. Okay, that was you. This is B. So U prime x and V prime x are the same thing except with the positive one and negative one. Wait, there's still the thing. So yeah, you don't. Apparently, you keep like what's in the parentheses here, and then you just put the 2x there. I don't fully understand it, so don't ask me questions. Probably ask Mr. Wilson. And then from there, you have to it. The answer.
Alright.
Welcome.
So this one was a bit more complicated. One thing that we talked about to do, especially when you have a complicated one like this, is I would simplify here before you plug stuff in. Alright? So on your U prime, you see a 2 and a 1/2. That's 1. Okay? And then it might be helpful for you to go ahead and write that as x over the square root of x squared plus 1. Okay? Or at least x squared plus 1 to the 1/2. Same thing with this. The 2 and the 1/2 cancel out to 1, and we have x over the square root of x squared minus 1. Okay? So now you have the u right here, okay? Oh wait, I'm sorry. You have the v right there. The rest of this is your u prime. Okay, so here's your u prime times v. And then you have over here u times v prime. Okay, well, u is right here. Okay, there's u. And the rest of this thing here was the v prime. Okay. Again, this is one where it's possible to simplify a little bit more. Okay. To get these simplified, you would multiply them by each other's denominators. Okay. Okay, so that's gonna get super complicated. It actually ends up being a little less complicated than you might think. Because the numerator ends up getting squared. Alright, so I'll kind of jump ahead a little bit. Here we're multiplying the first fraction by x squared minus 1 to the 1/2 over itself, and we get x times x squared to the 1/2, x squared minus 1 to the 1/2 times itself is just going to be x squared minus 1. Okay, and that's going to be over x squared plus 1 to the 1/2 times x squared plus 1 or minus 1 to the 1/2. Okay, then the second part of the second fraction here, I'd be multiplying by the x squared plus 1 to the 1/2. That's going to square this, so I'll get a plus x times x squared plus 1. I might say, well, what's the point in doing all of that? Okay. The point of all of that is this does simplify down. If you simplify your numerator, you've got an x cubed minus x plus an x cubed plus x. The minus x plus x cancels out and you get a 2x cubed. The denominator, if you remember, when you have square roots multiply, hold on. When you have square roots multiply, you can multiply them together and then put it in one square root. These multiplied together are x to the 4th minus 1, and that would be to the 1/2 power. Okay? So, that would be a fully simplified answer. Alright.
Have a good day.
See ya. Have a good day.